Characteristics of transistor. Let us study the VI characteristics of transistor and hence determine its input resistance, output resistance and current gain. Transistor is basically a semiconducting device consisting of three terminals having two junctions. The three terminals of transistor are emitter, base and collector. Given a transistor in a hand, these three terminals are identified by referring to the notch in the device. So, the terminal very close to the notch is identified as emitter. In the clockwise direction if you go, next comes base, the next terminal is collector. Among the three regions of a transistor, emitter region is heavily doped so that it emits charge carriers. Base region is lightly doped so that it transfers the charge carriers. Collector region is moderately doped to serve the purpose of collection of charge carriers. Transistors are of two types, namely NPN and PNP. Transistor can be connected in three different modes. They are common emitter mode, common collector mode and common base mode. Among the three, common emitter mode is generally used because it has higher gain. For the normal operation of the transistor, the two junctions of a transistor must be properly biased. That means the input circuit must be forward biased and output circuit must be reverse biased. Hence, the input resistance of the transistor will be less compared to the output resistance. Hence, the name transfer of resistor and transistor. Transistors are used in amplifier circuits for the purpose of amplification. Let us study the characteristics of transistor. Rig up the circuit connections as shown in the figure, wherein the given NPN transistor is inserted in the circuit so that the input circuit is forward biased, output circuit is reverse biased. It is done by connecting base of the transistor to positive of the input supply and collector terminal of the transistor to the positive terminal of the output supply. To record the readings, current readings, in the input circuit we connect a microammeter because current is of the order of microamps, and milliammeter is inserted in the output circuit so as to measure the output current. The bias voltages are recorded in the voltmeters. Input voltage is recorded across base and emitter junction, and output voltage is measured across the collector and emitter junction through the voltmeters connected across. Let us study the input characteristic curves for the transistor. So, we have in the experimental kit the two power supplies inbuilt and meters for measuring current as well as voltage, and to measure the collector current we have milliammeter here. The given transistor is inserted in the socket. So, connect the input power supply and output power supply to the circuit in such a way that input is forward biased and output is reverse biased. So that is how we do the connections. Now the circuit is ready. We'll start with the input characteristics of the transistor. So how to study the input characteristics? To study the input characteristics, we keep the output voltage as constant. That is, here VCE is maintained at constant voltage of around 10 volts. Volts. Now record the readings by varying the input voltage, that is VBE. So in this kit the VBE is measured here. So I vary VBE now in steps of 0.1, 0.2 and record the corresponding IB and IC in the meters. The readings are tabulated as shown. So for initial voltages up to 0.6, you find zero current through the junction. So as soon as you reach 0.6 volt, IB is increasing. Now vary in steps of 0 to volts up to 0.88. Record the corresponding microammeter reading as well as the milliammeter readings, tabulate them. Now moving on to the study of output characteristics. Reduce the voltage, set input current IB at 80 microamps, keep this constant. Now we are studying output characteristics. So input is maintained constant. Maintain input current at 80 microamps. Now vary the output voltage using output circuit. And record the corresponding milliammeter readings. So you observe that for very small current up to 0.3 volts, the current is small. After that, the current is increasing in very small step. So that means it has reached saturation and current is remaining constant almost. So I have increased the voltage from 1 volt to 3 volt. So the corresponding variation in the current is of the order of 0.1 volt, which says that the current remains almost constant as seen in the graph, model graph. So, initially there will be large increase in the value of IC for initial small variation in the input voltage. So, afterwards the current is increasing very in small steps, so almost ensuring the saturation region. Now, the graphs are plotted for input characteristics IB versus VBE, showing normal forward biased characteristics of a diode. Hence, the transistor input circuit behaves as ordinary diode. So, the slope determined in the linear region of the curve is evaluated, and input resistance of the transistor is obtained by reciprocating this slope of this characteristic curve, which comes around in the range of 500 ohms. Output characteristic curves are plotted between the collector current IC and VCE, which shows the variation initially for small voltages, large variation in the current, in the later stages very small variation in the current value, which ensuring the saturation region of the transistor, where actually the transistor can be used as an amplifier. Here the slope is determined, the reciprocal of the slope will give you the output resistance of the transistor, and which will be in the order of 2 to 5 kilo ohms. So, from the results it is clear that input resistance is of the order of 500 ohms, whereas the output resistance is in the range of 2 kilo ohms, ensuring the amplification. Current amplification factor is determined by plotting transfer characteristics. So, it is plotted between the output current against input current. So, output current is IC, input current is IB. So, IB is measured in microamps, IC is measured in milliamps. So, you see the linear variation, linear increase in the value of IC with respect to IB. So, IB is varied in steps of microamps, whereas IC is obtained in steps of milliamps, ensuring the amplification of the order of 10 power 3. So, the slope of this linear graph will give you the current amplification factor, which is in the range of 100 to 200. So, results and calculations are tabulated. So, result of this particular experiment is listed as input resistance of the order of 500 ohm, output resistance of the order of 2 to 5 kilo ohms, current amplification factor or current gain beta is nearly 200. The probable viva questions of this experiment is listed as shown in the slide.